Okay, hi and welcome to another PlayBASIC video. Today we'll have a bit of a look at a very old example that's on the boards. For a couple of reasons, which will become obvious when we look at the code. If you don't know, we've actually run various game making competitions over the years, and I just went to the wrong board. Fantastic. Where is it? There it is. Retro Remakes. Oh, is it this one? Oh, I think it's in this one. Yeah, there it is. So this was the first one, I believe. Not sure now. And we had 4 completed games. Well, kind of 3 completed games and 1 sort of half-finished game. So we had Dig Dug, JetPAK, and the idea was really just to remake an old game or make something that's going to feel like it's an old game. And one I wanted to look at was actually JetPAK by Ian Price. You can get the source codes stuff from over on PlayBASIC or over here. But be warned though, these are the original versions of the sources, and they're written in very old versions of PlayBASIC, and that's why I've been looking at this one in particular, because it doesn't have a few bits and pieces. In fact, it's the code. Out of all of the examples that I found that are older, this one was in particular very hard to get running. So I found myself spending a bit of time on it, and I have been rewarded by finding a few bugs in PlayBASIC that need to be fixed in order to make it run correctly. I'm talking about I'm using PlayBASIC 165, which is the new runtime, which is kind of a rewrite of the back end, if you want to think like that. So the code itself is all one source file. It's kind of the trend that people used to use. Bit of a shame, but you can add different pages to your source if you really want to. You can create a new source file and put that in, bundle that with your project as well, so you can split things up if you like. Anyway, Ian wrote the game. The game is actually cool. Nothing wrong with it. Good fun. And for those people who know JetPAK, it's kind of a classic shooter. Classic sort of 8-bit shooter. I don't know if it was on the 16-bit generations or not. It probably was, but I'm sure somebody out there will be able to find some videos of that or something. The main problems with getting this game to work was actually how it handled sprites, and as a result of the way it handled sprites, there was a bunch of logical problems it just would fail. In old versions of PlayBASIC, if I just make a new project over here, so we don't just destroy that bit of code there. In old versions of PB, you could do something like this. You could go for index. I'll call this variable sprite index. So 1 to sprite 100. I could just go position sprite index. Put them all at 100, 100. Now, if you're familiar with how sprites work, we want to make sure that these sprites exist before we ran this. If I run this bit of code here, we should get a runtime error. And we do, saying the sprite doesn't exist. Now in old versions of PB, that never used to happen. Which meant you could, anytime you accessed a sprite or media inside PB, like sprites or images or fonts or banks or whatever it happened to be, it wouldn't return at runtime. So when JetPAK was written, that's kind of being used as a feature, which is a bit of a problem. So as we run that old code on in newer versions of PlayBASIC, it just stops every time it sees a bit of code like this. It's looking at sprites that may or may not exist. We'll have a look at an example of a loop like that. Go to main over here. Okay, these render routines here got to run through all of the sprites that he's using. And how it worked originally is this status check wasn't there. So it was just in the end, if closing end if there, it wasn't there. So it would run through, he's using his counter as n from 1 to 500. So it's assuming the sprites exist between index 1 and index 500. If we try and query the sprite's local data, because this is actually how it's storing all of the properties the sprite has, it's storing actually inside the sprite, which is another one of those a bit dubious kind of methods, but you know, it works. It makes it very hard to read and understand what this program does. At this point, you know, wherever it is, 10 years down. When was this made, actually? When was this made? What year was this? 2006. Wow, so 11 years ago, maybe something like that. A long time, anyway. Hell of a long time. So, you know, obviously when the person was writing this game, they knew what these offsets all were. They were very clear about what they were going to be. When I look at this code now, I have no idea. Today we would use something like types, and you could have used types at the time, but I remember having a conversation with the author who was very unhappy with the way types worked, and it's like, oh, this is a better solution. And I sort of went, okay, if you say so. A bit of a candidate for a function there. The same piece of code is literally cut and paste all through the application. It's drawing a little scanner box, like a mini map sort of thing. Anyway, so what this code does is it runs through and it's looking for, because I've looked at the code recently, it's looking at a sprite and grabbing the integer at offset 16 inside the sprite, inside its local data. And this offset 16 is used as the classification. What kind of sprite object is this particular sprite being in the game? You know, is it the player? Is it a bullet? Is it an alien type? Which is what comma 16 actually represents. So if it is the alien that's looking for, grabs its position, it's doing a physical comparison against some secondary image to see whether the sprite has hit the hard part of the background. A bit of logic to stop it from falling. Resets its Y coordinate, moves the sprite relative to some magic scroll value, and plots it in the scanner. Now, of course, if all the sprites from 1 to 500 exist, this will work fine. But if any of them don't exist, modern versions of PB would come through here and go, hang on, you're trying to read data from a sprite that's not allocated. And it will stop and say, no, that's a runtime error. To fix that, I've had to run through and check, just query whether the sprite exists first, and if it does, then we let it fall through and do its original logic. Okay, and that's the main problem with the code actually. There are some situations where it was doing a bunch of different things in one big loop, and it would sort of have these kind of little logic problems in it. Which example are we looking at? That one? No, that one. Yeah. Okay, so imagine that this is our sprite control loop, and here we might, you know, we're going get sprite local int, using a sprite index, and the value we want is stored in position 16 or something like that. Let's say we're looking for a sprite which we've pre-classified as type 18. Now these are just magic numbers. So you could go through and you can have some code that moves the sprite or whatever. Have some code that detects collisions. Find a collision. If it collides, let's say we want to delete the sprite. So we might just have a bit of code here, kill sprite on collision. So we might have, if our collision status has been tripped, then we delete. Delete sprite index. I'll just make that a bit more kind of like the code that's actually in JetPAK. I just want to do it on screen so you can kind of see or get an idea of what the kind of things I'm talking about that are happening or were happening. There's probably still some more of these hidden away in the code, by the way. I'm just going to tick through it, to be honest. Let's say that at offset 4 we have the sprite's x coordinate, and at offset 8 that would be its y coordinate. Right, so we're reading the coordinates here, moving the sprite in some direction, who knows, checking for a collision, and if there is a collision, if our collision flag here has been tripped, then we delete the sprite. If you have a look at that, that's also going to create a runtime error. So when we're living through this loop here, we come up to this line here. Geez, I'm rushing this. But anyway, we come up to this line here. We go, okay, you're the sprite I want. What we should have out here as well is get sprite status. Just make sure we're never attempting to read from a sprite or an image or any kind of resource that's built into PB that doesn't exist. So we come through here. Sprite index is 1, and there's no sprite 1 allocated. The thing just jumps over down here and loops back. The sprite index counter is bumped forward by 1, so it would be 2 on the second time through. If that sprite existed, we go, okay, cool. This time we would run the code inside here. And if by some sort of magic, there just happens to be this sprite type 18, whatever that's meant to represent in our game. We go, okay, we're looking for this type here, we found it, let's move the character and do what kind of update logic we need to do for this frame. So we're grabbing its position to wherever it's stored, find a collision. If it hits something, let's kill it. If we get to here, we delete the sprite, then after that's been deleted, it's going to fall through and try and position this sprite that was just deleted straight away. And it will pop a runtime error. That sprite no longer exists, so we can't position something that doesn't exist. Wow. That's kind of a talk through of what these kind of logic errors were. There are a number of them. Let's try to find I think create alien. No, it's not the one. The game uses a kind of general create alien function, and it's kind of picking what to build based on what level we're at, really. So it's going, oh well, that's the 8 monster, that's something else, whatever. At the very end, it actually initializes the sprite down here, and you can see the structure it's using internally. So we're creating some local data in the sprite, and we're storing all the properties inside the sprite itself, which is kind of neat. You know, it's all inclusive. It's not the best way of doing it, but it does actually work. You could, of course, go through and I was thinking about doing this before, is actually making a type structure out of all this. I'll make it down the bottom here, just as an example. You have type and end type, and you know, I don't know, sprite props or whatever you want to call it. So the first field, because we're at offset 4, I think that's probably a status field. We need or we'll just call this empty. So X was at offset 4. This is at offset 8. Direction. That's the type of sprite, I'm assuming. It's animation, starting position, it's last position. Don't have a clue what that is. You know, just call that unknown for now. Alright, I'll just comment those out just for a second. I could go through and build up a type that represents the same structure, and here I could create the sprite locals here. I could dim, we'll just call it my structure. I'll call it props. Yeah, that makes more sense. As sprite props pointer. So we initially props would be empty, so we need to get the get sprite local pointer. It's alien. Now it actually points at the data. So you could actually just go props x equals x and fill in our structure as per usual, and you're actually writing that data, poking the data in like it is there. That wouldn't work the way it is there, but because that would need the type declaration prior to seeing this in the code. I have to move this up the top here somewhere. Preferably the top of the code, but okay, so you kind of get what they could have done with the code to clean up a little bit, and we would get rid of all of these function calls, the ambiguity of what these offsets, sorry, that one there should be Y, all these offsets in the code are. Certainly something, if you feel like a bit of a challenge, might want to go through and have a bit of a go at it. The other thing that wasn't working in the game was that the game makes a collision map at some point. Just trying to think of what the function was. I think it's create platform. No, it's not it. Create bullet, no. Create snake, ship, rainbow. Yeah, I can't see it now. I'll check out the main function, it might be in here. It creates it draws a background as a picture, and it's pulling using a whole bunch of points commands to do collisions. So if you just search for point, and I'll go forward. Yeah, here's a good example of one. So I don't know what function this actually is in. This is one of the AIs, one of the characters. So AIs, even these here, this should be a select case. You know, you would get rid of a whole bunch of function calls in a row that just aren't necessary. Anyway, so the code in here is doing kind of a classic, kind of a lazy thing, really. What this probably should do is it probably should be using fast point, for example, and clip the starting x and end x to the image's width and height, so it won't read off the image, so nothing unusual will happen. But originally it wasn't. It didn't lock the buffer, and the image it was reading from was actually NVIDIA memory as well. So just all this extra overhead it was doing for these point tests. And I think every character that has collision does the same thing. Another routine there. Test platform positions. There you go. I think that's the player. Delete layers. Well, that one there is not actually not locking the buffer. If you don't lock buffers, every time you call point, it has to do a lock and unlock, which is kind of like a please and thank you mechanism. Not much fun. Another one. Unlock, lock, point. Yeah, it's a whole bunch of them. Unlock. I don't know what this does actually. Okay, we're going to skim through all the code there. Generally it's written pretty well, except for those couple of sort of design faults. There are some sort of oddities here, like if you look at the render functions, we are just assuming that our sprites are never outside of index 500. Probably what they should have done really is step through the linked list of sprites, which is, you can do get first sprite and this kind of thing where while this sprite is bigger than 0, and while this sprite equals, get next sprite. And that way you only ever move through sprites that exist. You start from the start of the sprite list and it just moves to the next sprite as you go through. So in here you would do, you might check the sprite's type or whatever it's doing. So to bend this bit of code here to suit that approach, you would do using the variable, and we don't need to check if the sprite exists anymore. So you do something like this. We're using n for the index, caps lock stuck on. So we have the while n to make sure that our sprite is still within a legal place. N equals get next n. Sprites most media inside PB is stored in a linked list, and it links to the indexes, so you can the orders the indexes come back in could be any order. So it might be the first sprite might be sprite 52, and then might link to sprite 102, back to sprite 5, 10, whatever. It doesn't really matter. So our sort of, this version here gets rid of the old problem with, now we know that we're always running through here. When we're inside the loop, we're always looking at sprites that do exist. That's the same way you should use for collisions as well, by the way. Okay. I can't really run this game on this computer. It's unfortunately on the little HP system, which is okay for capturing on, but not much really runs on it. Now code-wise, what's the last little thing there? Okay, the title was drawn as a, it was drawn as using a draw alpha image, but we're loading the image as a video image rather than an effects image, which is a bit of a no-no as well. You don't really want to be doing that. Overall, the code's pretty cool. It's a cool game, so I'll chuck up the revised code and you can have a go at updating it yourself. It does use a few practices that I don't personally recommend. Like, we've got a lot of global variables here, a lot of magic numbers sprinkled throughout the code, which is a bit of a shame. And using sort of more modern approaches, you can simplify most of it. In fact, you can probably cut the code length in half if you tried. Well, I'll give an example. You've got aliens here, right? You can seed the table by using split array. Sorry, once it's delimited there. So you just have a list of names in here. What was that? Jelloid, etc. all the way through. And that would build the same hard-coded list of these things as you go through there. I would generally do that kind of stuff externally. Just load the file and then split it, bang, done. This is the image that it uses for its collision map, which is an invisible image that you never see. But there it is. So this is where it sets up the collisions. It draws a large image in the background, and then draws boxes on it, solid boxes of a certain color. It just does pixel checks against that. I don't know why they didn't use map collisions in it, actually. That stuff was in PB way back in the time. I could have just used rectangle intersections as well. Don't know. Well, might have been a bit buggy. I mean, who knows really now. This is 10 years ago. So we're setting up the game there. A few title screens. In this version, you can just kind of hold F2 and select which level you want to start at. I did notice that the call DLL stuff seems to be crashing in this version, so that might be a PB thing, or it might be the DLL actually. So they both could be at fault there. Bit of a classic no-no there as well. I mean, in modern PB terms, you wouldn't do an ink and then a dot. You would just use .c, which is just our sort of crass way of saying a coloured dot. And you don't change the ink colour at all, so it's one less function call, and you really should have a lock buffer in here as well. So we're making sure the buffer is locked, which means that now that when the buffer is locked, when the dot command is called, it doesn't have to do please and thank yous when it's asking for the surface. Because Windows is a multitasking environment, and these environments can do things in the background, so the memory you think you're rendering to can be effectively expunged. So you have to lock the surface and write to it and then release it at the end. If you don't lock the buffer yourself, then every time you call dot, it has to do this, and sometimes the lock process has to wait for something else to release the buffer you're using, or to release another buffer it's using, because yeah, it's complicated, I know. Wish it was simpler, but all the basic code there, it all looks pretty okay. There is a bit of I did notice that in the text function here, classic sort of PB isms that just aren't really used. See, we've got the mid dollars function there, so we're grabbing a character from this string as a string, then getting the ASCII2 value. You can just do this. You can just go mid like that, and it's the same thing. This one's probably 10 times faster than this expression here, so it's not a big deal when the string is very small. It doesn't matter. But when you try to run through strings that are a few kilobytes long or 100k long, let's say, it's a massive difference in performance. Okay, that's probably enough sort of picking away at the code. It's a very cool game. Definitely please go and have a go at the game, and Ian did a great job with it back in the day, and wouldn't mind updating a little bit as a fun experiment and another way of helping me beta test PlayBASIC 165. All the more coding I do with it, the more things are uncovered. I found a couple of bugs in this that were PB bugs in this game actually. One was with one of the logic routines used random range. I think the expression was this. Yeah. So in old versions of PB, this was a VM operation that's pre-PlayBASIC 165. In newer versions, this is a standard function. Now, that introduced a bit of rounding to it by the way the function was called, and so the function now has been updated to make sure the rounding is not an issue. As a result, in old versions, this randomization here would make the character randomly move up or down each frame. In newer versions in 165, this will only move up. So the value could never reach 1. It would always be either -1 or 0. Bit of a pain, but actually a hard thing to track down at the time. And the other one was to do with not, and the expression evaluation was causing that to break. Not something. No, it's not it. Yeah, that's one of the expressions that was broken. I did have to change the logic here. I had to bracket it. It was deliberately. It needed to not. So it was assumed that the not would flip the state of these key control here, and then AND it to these here, which old versions of PB do for some reason. Yeah, that's a bit of a strange one. That's strange because not is actually tagged. It was meant to have a lower precedence than the AND and the OR operator, so they should have been done first, and then it should have done not at the very end. But it seems like at some point that's been changed or it's been added. I don't know, but it wasn't working the way it used to work. but no one seemed to notice anyway, so it doesn't matter. Probably someone did and didn't bother mentioning it. Anyway, so that's a bit of a look at JetPAK. Just run the title screen for you. Pretty much have to capture this externally because it's, oh sorry, yeah, I've got a bunch of mangled code in the middle of that. I just forgot about that. I forgot I was kind of mangling the code as I went through. Too many parameters for mid. Oh, of course there's too many parameters for mid. We don't need a third parameter because we're only grabbing the byte value of that character. We can't grab multiple bytes. And there's JetPAK. Alright, so thanks for watching, and make sure, hopefully you'll sort of go and have a look at some of these old examples. I forgot how good some of them actually are. Lots of awesome old people wrote them. It's been a lot of their free time making them, and they deserve the credits they got. So I'll leave it there, and thanks for watching, and make sure you go check out some of the old games. They can be lots of fun. Thank you, and bye.